那么今天我们接下来一题就是请到了 STF 的作者 Simo 来给我们分享一下关于他是如何去 creating 这么一个 STF 的一个过程的。OK，let's welcome Simo.
Hello. So I'm Simo, and I'm going to talk about how we created OpenSTF. So let me just do a little bit of setup work here. Okay. Let's begin. So I don't like to speak so much about myself, but I'm Simo. Just call me Simo, that's fine. I created OpenSTF with this another guy in 2013. Of course, it has already been about 5 years, so a lot has changed since then. And you can check out my personal GitHub if you like to. I've also released some other open source stuff before. So I think many of you already know, but I'm going to speak a little bit about what is OpenSTF. So this might sound more complex than it actually is, but basically OpenSTF is an on-premises, free, and completely open source device management platform. Most importantly, it comes with an Apache 2.0 license, which allows you to do pretty much anything with it. So for example, you can take the code, you can sell it like that, you can take some of the components, you can use them in your own product, and that's completely fine. Although, if you do that, I would hope that you provide some contributions back to the project. That would be much appreciated. We have about 7,500 stars on GitHub, and we also have about 20 repositories, so the combined stars are about 10,000. And you can kind of compare this to, for example, like AWS Device Farm or Google Cloud-based Lab, but of course, the paid solutions are usually much more refined. So what does it do? So it provides remote access to devices. So for example, today we saw the AirTest platform, but many of those things didn't exist 5 years ago. So the way to test, for example, a game that didn't really have elements that you could get an accessibility ID for, you would do manual testing. So our platform is mostly for manual testing. But you can also use it for monitoring test runs. And for example, like let's say that you run into an issue in a test run, you could basically open STF and see what's going on, and you would try to recover that device. And one of the really important points is that it integrates with basically all existing tools. As long as the tool supports ADB, it can integrate with OpenSTF. So you can use it with Appium, you can use it on Jenkins. Yes. Louder. So I guess I have to speak louder. Sorry about that. I hope you can hear me now. Okay. So it integrates with Appium Jenkins. It integrates with Android Studio also and ADB. So for example, in Android Studio, you can see a device from OpenSTF as a debug target, or with just plain ADB. You can even do like an ADB shell command and do pretty much anything on the device. So it looks like this. So you have, this doesn't come with the project, by the way. You have to make the shelf yourself. But if you have a nice shelf, it can look like this. So this is what it looks like when you use it. So it goes by pretty fast, but basically there's a device list, and you choose a device that you want to use, and it opens up. And this is a GIF, by the way, so the real frame rate is actually much nicer. So why would you use OpenSTF? I think many of you already know, so I'm not going to speak so much about this. But you can use hundreds or thousands of devices. it supports like almost any device. There are a few that don't work, but most of them work. It runs on relatively commodity hardware, like as long as you know to avoid certain things. It's pretty easy from a user point of view, but it's not so difficult to, it's not so easy to install, unfortunately. And it's completely open source, so you can modify it and you don't even have to publish the modifications. Although it would be nice if you did. So OpenSTF can be good for you, but this is an open source project. I'm not here to sell this to you. So what I'm going to speak about today is about how OpenSTF was created. And looking back, it has already been about 5 years. So now we know that some things didn't really go as we planned, so we can take some lessons from that and evaluate how we did. And we can also take a look at some of the things we might do in the future. So to understand some of the choices that we made when creating OpenSTF, we have to go back and just prepare yourselves. Yeah. So this is basically like the initial version. And as you can see, it sucks. It's horrible. It's like many of the cables, they're touching like other screens, and it's creating like ghost touch events on the other devices. It's just like really painful from a management point of view. So unfortunately, it didn't really work so well. But we created this project back in 2013, and we originally actually wanted to create a test automation platform. So it wasn't about remote control at all, and that's where the name comes from, by the way. So it's called Smartphone Test Farm, and it's very specifically says test, but OpenSTF doesn't actually provide you any tests. So remote control became a priority much later in the development lifecycle. So this was back in 2013, and we kind of realized that nobody was actually writing any tests. So to make this application, which by the way originally was an internal application for the company, to be actually used within our company, it would be much more useful if it could support manual testing. So that's how we did it. And we realized that we could build this feature when we were building a video capture feature for the original STF that basically recorded your whole test run. So going back to 2013, talking about Android, the latest version was 4.3, and we had the requirement that we must support Android 2.3 with our application, and we did, and it still works. Nobody uses it. So, some of the popular phones from back then, Samsung Galaxy S2, S3, many of the phones, they didn't even support LTE, and there was a surprising amount of variety. So for example, like some of the manufacturers that don't even exist anymore, although they do exist as a company, for example, like Panasonic, like many other Japanese manufacturers especially, they created many phones, but they don't do that anymore. It loses them money. So you didn't really have like this one or two entities like Samsung, Xiaomi, who are taking all of the market share. And mobile testing in itself, it definitely existed, but it was very immature. And many of the tools, they were quite unstable, which is understandable because everything was quite new. And it's like even the official documentation from Google was quite lacking, to put it nicely. And many of the tools were not open source. Almost nothing existed, with the exception of Appium, but at this time, actually it only supported iOS. So as a result, especially at our company, very few tests were actually written. So our challenge was to create a system that somehow supports these hundreds of devices that are present in our market, including Android 2.3 and basically every possible version. And somehow to make it easy to use, to make it usable so that you can basically just use the system without having to install anything. And importantly, to integrate with existing tooling. And we don't want to create a remote control solution and a test automation platform, because that's a lot of work. For example, today, just now, we had a talk about Appium itself, which is a very large project. Just imagine that somebody did both of these. It's a lot of work. Very happy that we didn't do it. So the initial prototype that we made in 2013, we had it kind of running in a few months, I would say 3, maybe 4 months. And it used ADB's undocumented frame buffer command to capture the screen, which was very slow. We used the monkey tool for input, which is the most unreliable thing you could possibly use for that. And just like some basic ADB commands, like ADB install to install applications and do some basic stuff. It was bad. So especially what didn't work, we had so many unpredictable disconnections on the USB side. And at this point, we didn't really know so much about hardware. And like overall, when you build a software solution, you don't really expect that the hardware is going to bring you trouble, but it does. And overall, just like managing those hundreds of devices and like setting them up physically somewhere, it was a lot of work. And at this point, with the initial prototype, only about 1/10 of our devices were actually fully functional. So due to especially monkey tool, many of the touch events, they didn't really work at all. In some screens, like the home screen on some devices, the manufacturer decided that we are not going to allow the monkey tool in the home screen. Or on some devices, for example, the settings application, monkey would stop working. Or on some devices, the software keys, you couldn't touch those. Or on some devices, you could scroll, you could drag, you couldn't tap. And tapping is quite important. So obviously, you didn't have multi-touch support either. And the frame rate was super bad. So first of all, what we did to solve the hardware side was that first of all, we had to do some research, and we found out that during development, Intel did some changes in their CPUs. So I think they implemented like a USB 3.0 host controller within the CPU or the chipset. And that basically decreased the number of resources that was available to USB 2.0, which is what most devices use. So we found out that you can only run about 8 to 12 devices per machine reliably. And that's not a very large number. And most USB hubs, especially consumer end, they're just really bad. They cannot provide enough stable power or just like enough power to both charge the phone and to maintain a data connection. And there have been cases where USB cables break, which is quite interesting. So some days you would come to work and you would find out that one of the devices is not connected anymore. And you would plug it in again, which usually fixes the problem. But it just doesn't come back. And you're like, what is this? You plug it into a different port, it works. And then you kind of start debugging again. You swap the cable, and now it works. It's magic, but it happens. You have to prepare for that if you manage a test platform like STF. And also ADB, it's just like so horrible on OS X. We initially used OS X to deploy STF, just didn't work out. So our solution to some of the CPU limits. So we use PCI Express cards with built-in USB host controllers. So we could basically get rid of that host controller limit on the Intel CPUs. Some other options that you would have would be to use more machines. You can do that. Costs more money. If you have more money, you can do it. And on some machines, like the Mac Mini, there's actually this secret command that you can use to enable a second USB host controller. So if you use Mac Minis, you can actually do that. Or you can use another CPU vendor, which also works. Not without issues necessarily. So our solution for the USB issues was a battery charging 1.2 compatible USB hub, which was quite nice, quite stable. And we also use this super hacky 4-port hub for older devices that was actually illegal. So it provided like way too much power to the devices, but it made some of the devices stable. So it was quite good for us. And now there are some devices, basically programmable USB hubs that even provide an API that you can use. And you have some other solutions like you can plug the devices directly into a machine. Don't do that, it almost never works. It might seem to work for like 5 minutes, but then it's happening again. And you can also try to reduce the power usage. For example, what some people try to do, they set the brightness to the absolute minimum value. It almost never works, don't do it. And you can just like use fewer devices per machine. Again, more cost. Or, recently, you can try to use USB over IP. I don't have so much personal experience from those, but from what I've heard, they can be quite unreliable also. And for the operating system, just go with Linux. It's so much nicer. Don't use OS X. And don't use Windows, please. And we had some surprising other limits. So for example, like ADB, the USB bandwidth that it uses, it maxes out at roughly 5 megabytes per second, regardless of device. So when you think about we were using like ADB's frame buffer command, a single frame buffer for a full HD device is about 8 megabytes. So obviously, we were not going to be able to support even 1 FPS, which is quite terrible. And just from an organization point of view, when you have like 100 devices or more, it's just not fun to manage. So our solution was to switch to woodworking and to build a shelf of our own. So we started from this. This is my desk. It's horrible. It sucks. Don't do this. It looked like really nice at night, so if you want that, you can try. So from this, we moved to this. This still sucks. Don't do this. But basically, this is still one of the desks that we had. And you can see that now we are using like more proper cables. We have like some dedicated providers, but we are like completely out of space, and it just sucks. Don't do this. And here's like a special shot from the floor. So next, this is built by me. Nice. So this is a wooden shelf. This is our initial prototype. This supported like, I don't know, you can count how many devices. It was quite nice, saved much space, really nice. But it turns out that I'm a pretty poor carpenter, so we couldn't build like more of this. It just took so much time. So we had them made based on our design. And it started to look like this. And this is pretty nice. So we had like about 3 of these shelves. And we had like about 200 devices. And we had like this, wow, now that I see it up close, it's really dirty. But we had like this mechanism that I designed that allowed you to rotate a shelf. So our design was to have, so camera was an important feature for us. So our idea was to have like a poster or something behind the shelf, and you could basically take a picture of that, so you could take like more interesting pictures from the device. And this mechanism allows you to rotate a shelf so that you can kind of like adjust the angle. And this is what it looks like from behind. And on the software side, for reliable touch input, so Monkey was gone. But it turns out, during our research, we tried many other things also, but it turns out that the ADB shell user belongs to the input group, and the input group has read and write access to these event drivers or the event devices. And one of those input devices is a touchscreen device. And if you write data in the correct format to this file, it will generate touch events on the device. And you can also use the built-in get event command to read 3D events. So our solution is mini-touch, and it's an ND-cabled binary. It doesn't use any private APIs, by the way. We will get to that later. And it automatically detects the correct touch device. It exposes the socket interface. It translates abstract commands into raw Linux kernel touch events. It supports real-time multi-touch, like as many fingers as the device supports, mini-touch can support. It has some additional requirements on some devices like Xiaomi. You have to do like this additional setting, which is kind of annoying to do, but you only do it once. And this basically fixes like almost all of the problems that we had originally. And it still works well. It's quite nice. You do have some options now. You can use ADB Shell PM grant to add this additional permission to an application, and then you can use Android Java APIs to inject touch events. And for the screen capture, originally we used the frame buffer, and it wasn't working out, it was bad. But the ADB Shell user, again, belongs to the graphics group. And the graphics group is allowed to connect to Surface Linker, which is the workhorse behind everything graphics related on Android. So it takes all the commands, it produces what the hardware is going to display for you. But it's a private API, so I'm sorry about this. Yeah, so again, it's an NDK binary, but because we use private APIs, we also have to compile against every single Android branch, which takes quite a bit of time. And every time there's a new Android release, we have to rebuild. And it uses the screenshot client for any older device. But even though it takes these frame buffers and it does something like really low tech, which is just to convert this to JPEG, it's actually really fast. It's surprising how fast it is. So you can easily get 40 plus FPS or even more. So it's almost real time, works on any Android version, including 2.3, but not the preview yet. And it can pretend to be a secure screen, so it can display like all views that have the flag secure set. And this relatively small JPEG file size doesn't completely overwhelm the USB bus. And it's pretty simple to use from a user's point of view. Of course, it uses private APIs. So it has to be recompiled for every new Android version. And what Google does with many of these developer previews is that they release the public build, then they release the source code. But the source code is not actually what they use to build the public release. And then even if you compile against the source code that they published, you get symbol mismatches, and it's quite horrible. So you have to do like a lot of reverse engineering if you want to support these developer previews from day one, and just don't have so much time for that, so waiting for that release. And there's a small number, a very small number actually, that don't work. I'm speaking about devices, by the way. But we have fixed many devices, and right now, if there's a device that doesn't work, I'm actually quite surprised. So it supports almost any device. And JPEG is pretty low tech, so that's a bad thing. So tooling integration is another important thing. So most tooling uses ADB, of course, because it's the Android debugging bridge. So as long as a device is visible to ADB, you can pretty much use it from any tool. So what OpenSTF does, or actually maybe I should mention, so with ADB there are two modes. One of them is USB, and one of them is TCP/IP. So let's say that you have a device, you connect it with a USB cable, you run the ADB TCP/IP command, you can disconnect the phone and connect to the IP of that device, provided it's on the same network, and it will work quite nicely, except it's super slow. It sucks, don't do it. But OpenSTF basically abuses this. So because ADB is able to connect to an external socket, OpenSTF pretends to be a device. So it creates a fake device, which is just a socket server. It takes in a connection, it maps that to a device, it does some authentication with your ADB keys, which are sent with the handshake, and it proxies requests to the real device, and then it returns the result. Works nicely. And the basic flow for that is to first install STF, then you create an API token in the UI, then you register your ADB key,
so it lets you in. And then you retrieve the ADB Connect URL through our API. Then you run that ADB Connect command. And now you have the device connected to your local machine. And you can see it in Android Studio, Appium, any tool. So what did we learn from developing OpenSTF? Like overall, if I had to evaluate some of the components that we have built, well, many of them are actually quite good. Like aside from Minicat, which is quite of a pain to maintain, they have actually held up pretty nicely, so many of them are still useful today. But what if I started a rewrite today? What would I do? First of all, I wouldn't use private APIs, so it's basically this once-a-year thing where you have to prepare a new release for a new Android version. And you feel like a real hacker when you make it work, but it's just like so much wasted effort, not really recommended. And I would rethink the architecture a little bit. And we get so many questions about how to install OpenSTF all the time. We should just make it a little bit easier and just like don't cheap out on the hardware. If you use cheap hardware, you will pay for that in time that you spent. And we expected more contributions to the project because we also use JavaScript, which is a fairly easy language. But in reality, people just take the source code, they make modifications, and very few people actually contribute back to OpenSTF. And if you have any contributions, that would be very welcome. And I would actually like to use Rust if I started today. And AngularJS wasn't like a decent, it was at the time, but it wasn't really it's not a good choice anymore in 2018. I would go with React. And it's like, it should be okay to abandon full backwards compatibility, and also community management has been difficult. So I was kind of hoping that we would take like some more of the initial contributors and take them as part of the team, but we kind of failed to do that at the time. So I would perhaps make a native application rather a browser application. It would be much easier and perform much nicer. And some of the insights into future features are, we are going to support Android P, hopefully soon. And we are going to hopefully get rid of JPEG rendering. So we actually want to do WebRTC over H.264, which would be very nice. And we would like to reset devices, but as we hear, it's not quite so easy. And also, we would like to support iOS. But again, for a complete 100% open source project, it's not so easy because it's a lot of work. And that's all.